up, what don't we like about it, Jack?
The 9 and the 3 on top.
Well, the 3 on top is perfect. We're going to leave that 3 on top, right?
The negative.
3 on top is perfect, but we cannot have this a to the negative 9. And so since it's in the denominator, we need to move it to the numerator. So we're now going to have a to the 9th power. I'm going to write it over here so you can see it a little better. So it's going to have 3a to the 9th. Do we move the b? No, but it has a positive exponent. That was b to the first, so it doesn't get moved. So now looking at that one, try the next one, okay? Only moving negative exponents, right? Only moving the negative exponents.
And that was the answer for
Okay.
the first one?
That is the answer for the first one. So if we are looking at the second one, am I answering the second one? Is that looking right? Just moving the g. So I should have had AB. I should have moved up D. It told us to move it up 2 and back 3. So up 2 and back 3, this is where my new point D prime is. C is going to go up 2 and back 3. If you only had these 2 pictures on yours, you did not finish the problem. It now says to do this last step, which I put up here in pink. And the pink says you are now going to take and reflect this A, B, C, D that we had in blue. You're going to reflect it over the x-axis. Looking at where my point B was, point B, if I'm counting, was up 4, so I'm going to go down 4 to this point, and this is my B double prime. So as we do our homework, sometimes you are going to be asked to do 2 or 3 different things. So each time, so you want to make sure you have this down, each time you want to label them in this way. And then sometimes what I'll have students do is they'll take a highlighter and they'll highlight their final answer. So this is the one that I'm really looking at for my final answer. Sometimes they'll shade it in. So when you are looking at those as you do your homework, okay? So we are looking at your notes right now for H2. You've just written down those 2 problems up here. Today we are going to be doing the reflections. We're going to be more specific. And I saw some of you started H2 in your workbook, which was fine. As we look at reflections, reflections is a transformation that creates a mirror image of each point in the figure. We have lines of reflections that you can reflect over. This is any line, but in 8th grade, we're mostly going to reflect over the x-axis. Our x-axis is always this axis when we're looking at our x-y coordinate. So we're going to reflect over the x-axis, and we are going to reflect over our y-axis. When you get into geometry in the high school, you will reflect over slanted lines in the coordinate planes, and then you'll do some that are totally not even in the coordinate plane, okay? So they'll just have a picture like that drawing we had yesterday that we were looking at. But in ours, we're mostly going to always reflect over these 2 for our standard. So we're looking at this point, and it says reflect the flag over the y-axis. Now here is the part where people will get mixed up. You might want to circle your y-axis and maybe put a little like line by that in your notes, because this is the one that you're reflecting it over. So if I looked, this point is 5 away from the y-axis. The new one, the top of the flag, is going to be at this point, right? If I look here, I go down 2. This is 5 away, and I could have this point right here being 5 away. They didn't tell us the letters going around here, so we don't have to put letters. And I know that I am going to draw a line from origin all the way out, right? So if I'm looking at drawing this line, I'm going to have going from the origin all the way here. And again, if you're having a problem drawing nice straight lines, use the edge of your workbook or your notes, right? Since we're in our notes, you might use your workbook. And then we want to extend this last one. So, and it says, so if we started at 0, 0, did that point change when we reflected it? Nope. No. So the first one, afterwards, please write down 0, 0, right? That one stayed the same. At this point, we went over 5 and up 5. Where's the new point? Negative 5. Negative 5. 5 is our new one. And you should be able to look at this next point down, right? It was 5, 3, so now it's going to be negative 5, 3.
Wow.
And then the last one. So it says, what do you notice about the coordinates that we wrote? They're not the same. What is the same?
The last one.
The y's are the same. So what do we notice? We notice that the y's stayed the same. What happened to the x's? They became negative. Now, they're not always going to become negative. We're going to think of them as the opposites, but here they did become negative. So if you are looking at this, it says the coordinates are the same, except the x values are the opposite. So when we are thinking about that, if we are going to write a rule, okay, so all the x's, because when we looked at this in our original, we had x comma y, and then down here, and the 0, 0 isn't a good one to look at, but then these became, afterwards, it always became negative x, and the y stayed the same. So when we write our rules, a lot of times our rules are going to look like these ordered pairs, and we are going to write our rule this way. So our rule is written this way. XY changes to opposite. Remember, this is the opposite of x. Please write opposite x. And then the y is exactly the same number. So whatever your x coordinate is, becomes the opposite, and then the y. So we're going to go to another flag one. This one was reflected over the y-axis, the top of the next page, notes. This time, we are reflecting over the x-axis. And the biggest thing where I'll have people make mistakes in their homework is they just think it's always either going over the y or the x, and it's the wrong one. So make sure you read carefully. So this time, we are going over the x, which is this line, right? So 0, 0, is that going to change? No. It was 5, 5. Now it's going to be what? 5 and negative 5. So write your new point. It was 5, 3. 5, 3. Now it's going to be 5 and negative 3. It was, if we were looking at it, 3, 3. It is now going to be 3 and negative 3. So draw it and write down those coordinates. Okay. Sometimes I will definitely ask you to give me the points. Other times, I'm just going to ask you to do the drawing. As we get going through this unit, sometimes they get to be really long with what we're doing. So what do we notice in this one? We notice that the y becomes the opposite, right? The coordinates are the same. The y values are opposite. So all the x's didn't change. The y's became the opposite. And our rule is written this way. Okay. The quadrilateral, and they're talking about the blue one, A, B, C, D. It says it's going to be reflected over this y-axis. And we write the new one, and we call it A prime, B prime, C prime, and D prime. So when you do yours in your homework, if they have letters going around it, or they tell you the letters to put the points, you need to write the letters by it, and then the prime, A prime, B prime, C prime. So I'm going to be able to see the original one and the new one. It says these two figures are congruent. Please make sure you underline that word congruent. That means they are the same size and same shape. Last year you guys did a lot of things with similar triangles, but these ones are going to have the exact same size and the same shape. The symbol for congruent, when we are talking about congruent, this is the symbol that is used. It's an equal sign with kind of like that approximately equal over the top. So anytime we are talking about the congruent, you're going to see an equal sign, kind of like with this squiggly line over the top, like that approximately equal. And it says if we would cut these two quadrilaterals out, and we could move them around to show that they are the same size. So if we actually cut this out on our paper, we could turn it and flip it over, and we should see that it is the exact same size and the same shape. So it says, is a reflection always going to be congruent to the original? If you just reflect something, should it always be congruent? Yes. Always congruent, okay? as we are looking at the top of the next page is where we need to practice. So a lot of times in your homework, what I will do is I will tell you, plot the points A, B, C, D. This one says to reflect over the y-axis. Now, when you're doing the reflection, I don't know that you need to list the points because we notice that C is 1 away. So now we are going to plot point C prime. Has to be 1 away from this y-axis. So we're going to have point C prime. We notice that B is 2 down from C. So 2 down from C is going to be our B prime. Okay? If I'm looking at where D is 1 away from the y-axis, so D prime. So I don't need to necessarily list the points, right? I just need to make sure I'm drawing it correctly. So you want to do this on your paper. Right here. So if we are looking at A, and again, A is 4 away, so we are going to put our point A prime. I notice that from A to B, this is just one diagonal across the box, same thing from A prime to B prime. So it says, are these two figures congruent? Meaning, are they the same shape, same size? Yes. So it says, look at the distance from the original point. Is the original distance at the original point is from the line of the reflection. How does this compare to the distance of its image point? Meaning, if D is 1 unit away, D prime is always the same distance away. So when we are looking at that, what are we going to notice about that distance away? That distance away should always be the same or equal. So I notice that A is 4 units away. I notice A prime is 4 units away from that line of reflection. Okay? So now we're going to take a look down at that next part. They ask us to reflect it over the x-axis. So again, just make sure you know which axis you're reflecting over. Sometimes people like to almost make a dashed line or put a line. That's the one we're reflecting over. So H was 1 down. I'm now going to put H prime 1 unit up. F was 2 down. I am now going to go 2 up and point F prime. I'm looking at G was 4 up from the x-axis. I am now going to go down 4 on the x-axis. And you always want to label them with the prime. And then you want to take and connect your points. And again, if you want to use your workbook, and some of these, you can kind of draw a pretty straight line just with drawing them. So I'm not going to be super picky, but as we get into more figures, you just want to make sure you kind of have those straight edges. It says a geometric orientation refers to the position on the graph. It says originally figure FGH is oriented in the center of the grid with the long narrow part, the triangle part in the top left. And a lot of times when we think about orientation, if we are going to go around this one in alphabetic order, we would go, what letters? The blue one. F, right? To G to H. And if we think of that going from F to G to H, are we going clockwise? Okay. If I go from F to G to H, this is clockwise. Okay. Or are you going counterclockwise, going this way? Okay, so this is our counterclockwise. Okay, which way would you say we are going? From F to G to H is counterclockwise. Okay, so now if we go to the new figure, and our new figure, right, we're going to go from F prime to G prime to H prime. I am now going clockwise. So this one was counterclockwise, right? That was our orientation. Now we are going clockwise. So it says, does the orientation change after a reflection? Yes. It changes to the exact opposite. This is only with one reflection. Okay? What do you think is going to happen if I do another reflection? It's going to go back to the original one, right? So kind of as you're thinking about these things, right? So the last two are going to ask you to do the reflection. So what I would like you to do right now, start the first one here. This one is going to have 2. I will have someone come up